Hi, good evening students. Today we are going to learn about design of machine elements. Nowadays there is a complex structures of any machines, engines. It is a challenging question for the design engineers at present scenario. So as you know that since last 5 years the electric vehicles will on roads. It is the toughest challenge for Indian engineers as well as whole world engineers, because lack of availability of the raw materials, or lack of serviceability, or lack of innovative engineers. So that goes to design engineers, and any company's final output, it is a profit. It depends on performance of design engineers. Once you see, so in the design of machine elements, so design of machine elements. One is the word design, another is the machine elements. What the design is? Design is process of formulating the new innovative idea to form the product. To form the product. That product may be machine, it may be device, it may be any structures. So where the machine means the complex structure of an all elements grouped together to convert the one form of an energy to the other form of an energy. Assembling of so many components. Example, more than 15,000 components in case of aerospace, more than 12,000 in case of automobiles, and turbines and big power plant, more than 25,000 components are all assembled together. So whereas elements, it means here the elements, so many components are grouped together to form one form to other form of an energies, because we need some linkages, elements. So those elements will be bolts, nuts, screws, washer, shaft, keys, belt, pulleys, drive, chain, it means levers and cams and all bearings. See how many components. Every component has an individual role. Togetherly, all they will work, convert to one form of an energy to other form of an energy. Understood what the design of machine elements. Now, see, before that I want to tell you is the design. It is based on 4C. What the 4C of design? Creativity, creating the new ideas, new informations. So, before, innovative methods, never it was existing in world. Never it was existing. Never existing before. That is called creativity, new ideas. So, whereas the complexity, it consists of so many parameters, so many components, not one or two. I told you already more than 25,000 components in aerospace, automobile more than 12,000, and normal engines more than 100, 500. All the parameters. It's a big challenging question for the design engineers. It should be minimum component, it has to expose the maximum work. So whereas the choice, when the choice means definitely there is a choice of solutions, possible solutions. In that possible solutions only, the engineer have to select which choice is the best suited for us. According to requirement product, it may be machine, or it may be engines, or it may be any product, protocol product. So you need choice, because you have to select availability from the possible solutions. And the compromise, because the multiple proximities, rapid maximum components. When the number of components increases, number of type of metals also increases, the cost of machines automatically increases. Estimated cost will be increases. Because one product, so many makers. One product, so many producers. And presently, see one product, you see how many product, one product, how many makers are making the products, and how the competition in this world market. And the growth is going very fast. Not only this, any sector, in all sector, it's a compromise. So there is creativity, complexity, choice, and compromise. So on 4C, this is simply called 4C of designs. So now we go for what is design. Design is the process of formulating the new innovative idea to construct a product, or device, or machine. It may be convert one form of an energy to the other form of an energy. Example, automobile engine, it converting chemical energy to the mechanical power. Chemical energy to the mechanical power. Where electrical motor converting electrical energy to the mechanical energy to the electrical energy, vice versa. So these all, the processing way is called design. Simple definitions. So what is the type of designs? One is innovative designs. One is new. Innovative means new. Never it was existing previous. Never it was existing previous. So new or creative. Whereas adaptive, already availability is there by redesigning something. You adapted some components. Example, Maruti 800, we converted into Maruti Alto. 800, it become Alto. How the conversion? It was slightly they were redesigned and slightly adaptations for the existing what availability, and they have made adaptations. So whereas here redesigning, complete redesigns. At present you see the nano car. It is a completely this all versus when BMW or lathe machines, milling machines, drilling machines, or mobiles, or computer system, laptop. These are how? These are redesigns. And now empirical designs. It means empirical design is the world past experience. Lot of experience based expert people what they have made, some analysis they made a constant. Based on that only the people are simply they will migrate. How example when you want to purchase a shirt, XL, L, M, S. These are the different approximate sizes. Not exact what we really require. It may be plus or minus, maybe dimension changes. So it may be so empirical. Some standard proportions based on that standard, every proportion go on varying. The dimensions of the remaining product will be varying on that standard. The standard is based on the new innovative ideas, research based and past experience and old ideology methods. So by elemental. So elemental means system. System consists of so many elements. Every element is responsible to do their own work. The way the design related to only elementals, components, small parts. One the so many component assembled become big part. So it is say system. What the system means here, system consists of so many components. By grouping the components similar working, you made a one systems. All grouping one side. All other grouping other side. So we can make 1, 2, 3, 4 all group it become a systems. The systems completely structured, different nature in work. So next is the computer aided. Nowadays most common computer aided. By using the computer applications or computers, we are designing the parts. It is called computer aided designs. And next is the mathematical. By using the mathematical relations or applications of engineering and science. That is mathematics. By the application of engineering science with mathematics. So we are designing the component. It is called simply mathematical design. Where industrial design is complete renovation of new industries. Whatever the present industry we are having, we go for new industry. Entire the objective will be different, but establishment will be same. Outcome is same, but manufacturing to convert the raw material to the finished products, whatever the materials we required, completely change of system. So it's a new industrializations. Now simply some other software like a CAD, next is a CATIA, ProE, Creo, ANSYS, Hypermesh, Delcam, Unigraphics, CNC, simulations, robotics and automations. Nowadays, these are more software products, software designs are eagerly waiting for innovative mechanical engineers and industries. Emerging need of these engineers. The expertization people in this field of CAD, CATIA, ProE, and ANSYS, Hypermesh, Creo, and CNC, simulations, and all these robotics and automations. Essentially, we need. At present, the whole world is eagerly waiting for competitive engineers and emerging need technology in the field of these software designs. Now, here, what are the factors to be considered while designing any component, any element, or machines or engines? What factors to consider? Very simple. One is load. So, here, what the load? The generally we have only static load, dynamic load, impact load, gradual load. Static load, dynamic load, impact load, gradual load. Whenever the component is working its own functioning, definitely exerted by any one force. Either in static condition, it is a rest, not moving. When it is moving, it is called dynamic, the motion, kinetic. And when the impact, sudden accident, suddenly it will jerk. When you put it again, suddenly it will change. That become jerk or impact, sudden change, gradual. Actually, gradually, first gear to second gear vehicle is moving slowly, suddenly go on, moving gradient. The gradual. By considering these loads acting on that machines or device or element. So the mechanisms, what the mechanism? There are so many mechanisms, straight line motion or rectilinear motion or simply circular, cyclic, and here angular, it will be angle oscillating or 4-bar gear mechanism, bull bar gear mechanisms, reciprocating manner, and so cycloid, epicycloid, hypocycloid, and these all comes under different mechanisms for before designing any machine or device. Manufacturing process. What the manufacturing? There are so many manufacturing processes because you are converting raw material to the finished products. Raw material to the finished products by using the different operations, different machines, different operation. So forming, we can make the desired structures either with a blanking process or what they need to design in a sand art body. So we can make it forming. It means required shape, approximately required shapes is required. Next, the casting and founding. By using required shape after forming, you can make it a cavity. After casting, the solidification product becomes the blanking, required size cutting. And the piercing, central part remains, outside of the blank should remain. And the way machining, which operations you can do, say it is the planing, turning, milling, threading, cutting, grooving, all. You can make it on machinability. And where the embossing, so make it stamping and sizing, required part. So where the forging, by application of heat, you can convert one form to another form of a part. Where the machining, it is repeating the same, it is also. Where the welding, wherever the two part components together collectively, so it becomes weldability. We all want to join soldering or bridging or welding. In permanent way, not riveting method. And wherever selections of materials, for the selection of materials means the metals, non-metals, or steels, and nowadays become more, it is a composite materials become more standard now, essentially emerging need of an all automotive industries, all manufacturing concerns. Same size, structure, appearance. Size should be very compact in size. And structure should be very simple and should have a long life. Shape, size, appearance. You need very beautiful appearance. While purchasing a car, you will see the appearance. How it makes appearance very pleasing, good appearance. Please look. So next is the effect of environment. So effect of environment in any normal conditions. It is in any atmospheric climate conditions. So that due to this climate condition, there is no change found in the proposed machines. Never change its functioning. Either it may be climate conditions, it may be say rainy seasons or summer seasons or winter seasons. Where the durability, what the durability means generally, so whenever with ability to resist long time with the different climate conditions, it is durables. Any climate condition should not affect. It's uninfluenced by climate. So with reliability, with respect to the given timings, estimated life, every component has estimated life. All vehicles 15 years, or you can say 3 lakhs kilometers. With respect to the given estimated life, it should not face any troubles by the customers. So estimated life should be given by the manufacturers. Each and every component, example, all tools component, these are only 5 years. Wherever the 5 years, you will scrap down, you go for new. All engines, vehicles, all these machineries approximately say in case of 15 years, or it may be 3 lakhs kilometers. After 3 lakhs kilometers covered by the vehicle, you can crush it. So next is assembly. It should be very easy to assemble. It should not be complicated. Then it becomes very complicated to make the engineer's product. They should be easy assembled or no texture can assemble. And the estimated cost should be less. It should not be overestimated because the same product there are so many makers. Example of person simple two-wheeler. There are so many two-wheelers, different model, different company. Range is just only 50 to 60, 70, 80,000, 1 lakh now. So service conditions, easy serviceability after getting in during service. It can't invite any troubles. The troubles can be easily minimized by servicing or maintenance or scheduling or repairing or all. Now mechanical properties, this all hardness, very important component. Hardness to resist, the ability of material to resist wear and indentations or scratches is called hardness. Where the strength means its ability to resist the load. Load may be whatever to be the type of the load. So where the malleability drawn can be thin sheets, required dimensions. Where the ductility thin, it can be ability to draw the thin wires, very small 0.001 mm diameter. And the brittleness due to the rexures of load exerting on that, it should not become the two-piece. It is the powder form. So where there is a hardness, it is a resistance, it is hardness almost where it came. And elasticity, it can be drawn into thin sheets a while. So after remove the load, it can regain elasticity. Where the plasticity, it remains permanent deformations after exerting the load. Permanent deformations. Where resilience, it is to absorb the energy for its shock. Absorb the energy during it will stop absorption. Almost all our suspension systems were resilience method only. Where there is elasticity, it can be drawn into thin sheets. It is a thin, not thin sheets. Elasticity of material to resist, it can be elongate after certain load. After sudden removal of the load, again regain its original positions. Regain its original positions. Where it is machinability and whatever the mechanical process will operate. So these all can able to do this all machining ability or cleaning, milling, planing, turning, threading, welding, weldability, joining, all should be machinability. And here weld and castings, it also is one of part. And the creep, it is a continuous deformations due to the temperature at constant stress with varying temperatures, it remains deforms permanently. Slowly and gradual change in its movement, it is called simply a creep. So these all we required is elements, machine, and a design, and what the 4C consideration, and a design, what the different types, and here what essentially we need. So presently, this is a challenging question for all engineers in the field of manufacturing, design, service, testing, research. Okay, I hope you understood better this complete theoretical topic. Thank you. Thank you.